Welcome back. We will now move over to part 2 of the 10th chapter. In this session we will be learning more about pointers. The pointer is a variable that holds memory address of another variable. In C++, you can convert one type of pointer into another, using explicit typecasting. Here are some features of the pointer. Number 1. The pointer points to variables, arrays, functions, strings, structures, class. Number 2. Pointers can be returned from a function. Number 3. Pointers support dynamic memory allocation. Number 4. Pointers help to interchange values within variables without physically moving them. Pointer variables. A variable that points to the memory address of any data storage location is called the pointer variable. It can be declared by a base data type and a pointer to the variable name. Syntax for declaring a pointer variable is datatype * name. For example, int *ptr. It simply means that ptr is a pointer to an integer variable. Pointer operators. There are two special pointer operators: asterisk and ampersand. The pointer operator asterisk is a unary operator that returns the value located at the address a pointer is pointing to. It is also called the value at operator or the indirection operator. For example, *ptr. The address operator ampersand is a unary operator that returns the memory address of its operand. For example, ptr equals ampersand of a. Let's revisit program 11 from chapter 7. It was our first program on pointers. Requirement is to declare integer variable I as 18. Print value of I using pointers. Also print physical memory address of the variable I. On line 5, we declare int I, * of p. So, memory space to store the variable I and a pointer named p to store address of an integer are physically created. On line 6, we have p equals ampersand of I. This means, store the physical address of I to the pointer p. So the physical address of I is stored in the pointer p. On line 7, we assign the value 18 to I. On line 8, we instruct the computer to print the value of I with the usual cout I statement. And so, on the output screen, we have it printed. On line 9 it says, print the value within memory location that the pointer p is pointing to. P is pointing to variable I. So here, the value of I is printed. On line 10, we are printing the physical address of integer variable I, using the address operator, ampersand of I. On line 11, we are printing the physical address of integer variable I, by invoking it from the address that is stored in pointer p. So this is how the basic concept of pointers work. We will go deeper into it in this video session. Pointer expressions. The expressions in pointers follow the same rules as with other expressions. This section examines a few special aspects of pointer expressions. Pointer assignment. As with any variable, you may use a pointer on the right-hand side of an assignment statement to assign its value to another pointer. Here is the code for a test program where the requirement is to assign a pointer to another pointer and print the second pointer. We first declare an integer variable x, assign it value 12. Then we declare two integer pointers, p1 and p2. Then the memory address of variable x is stored in pointer p1. Next, the memory address of pointer p1 is stored in pointer p2. Finally, we print the address of variable x, not value of x. Look at the output. Pointer arithmetics. There are only two arithmetic operations that you may use on pointers: addition and subtraction. Now let's consider the following expressions. Number 1. Plus ptr. It means ptr equals ptr plus size of data type. The plus operation on a pointer increases memory address by 1. If ptr is of type int and ptr equals 2000, then plus ptr would store memory address 2002 or 2004 and not 2001. The reason for this is that, each time PTR is increment, it will point to next integer which is 2 or 4 bytes away. The same is true of decrements. Note that, memory space occupied by an integer is 2 or 4 bytes, depending on your system. Number 2. Minus PTR. It means, PTR equals, PTR minus size of data type. The minus operation on a pointer decreases memory address by 1. If PTR is of type int, and PTR equals 2000, then minus PTR would store memory address, 1998, or 1996, which is 2 or 4 bytes less than 2000. Number 3. Asterisk PTR. It means, add 1 to the value which is pointed by asterisk PTR. The asterisk PTR increases the value that is located at address pointer PTR by 1. In this example code, see out statement on line 3 prints 11, which is the value pointed by PTR, plus 1. Or, 10 plus 1, which is 11. Number 4. Minus asterisk PTR. It means, subtract 1 from the value which is pointed by asterisk PTR. The minus asterisk PTR decreases the value that is located at address pointer PTR by 1. In the given example code, see out statement on line 3 prints 9, which is the value pointed by PTR, minus 1. Or, 10 minus 1, which is 9. General rules for pointer arithmetics. Each time a pointer is increment, it points to the memory location of the next element of its base type. Each time a pointer is decrement, it points to the location of the previous element. When applied to characters, pointer arithmetics will appear as normal arithmetics, because characters are always 1 byte long. Pointers will increase or decrease by the length of the data type they point to. You can also add or subtract integers to or from pointers. The expression P1 equals P1 plus 12 makes P1 point to the 12th element of P1's type, beyond the one it currently points to.